we will look at the concept of galaxies, starting with the structure of our very own Milky Way. This is a photograph of our neighbor, the Andromeda Galaxy. Andromeda, or M31, is what our galaxy would look like if we could view it from deep space. Our Milky Way is 100,000 light-years in diameter, compared to the Andromeda that is 300,000 light-years in diameter. The Andromeda Galaxy has over 1.5 trillion stars in it and is 2 million light-years away. This image is a drawing of the Milky Way galaxy.
Notice that it resembles an old spaceship because side-on view of our galaxy is what the 50s space people were into.
The size of our spiral galaxy is 100,000 light-years in diameter. From the Sun to the center of the galaxy is 26,000 light-years. From side to side, where we live out here in the disk, it is 2,000 light-years in diameter.
So the Milky Way galaxy is 100,000 light-years across. It's 26,000 light-years to the center, and we live out in one of the spiral disk arms. Since we're inside our galaxy, we cannot see what it looks like from deep space, but we have a twin spiral galaxy called NGC 891 that is also 100,000 light-years across and is approximately 30 million light-years distant. And so this is what our galaxy would look like from deep space.
A galaxy is defined as a large assemblage of stars, gas, and dust bound together by their mutual gravitational attraction. The Milky Way galaxy is where our solar system resides. Galileo was the first person to view the Milky Way through a telescope, and centuries of observations since Galileo have confirmed our solar system is part of a galaxy. The Milky Way alone contains about 600 billion stars, along with dust, gas, and other matter. Most stars in the Milky Way galaxy are located in a disk that resembles an old science fiction movie.
Yes, hear that again. Within our own Milky Way galaxy, we know of over 600 billion suns, all performing thermonuclear fusion in their cores. These 600 billion stars make up just our galaxy. There are billions of more stars in the other galaxies.
A spiral arm galaxy is a flattened, rotating galaxy with pinwheel-like spiral arms winding outward from the galaxy's nuclear bulge. Spiral arms are lanes of interstellar gas, dust, and young stars that wind outward in a plane from the central region of some galaxies. Our galaxy has at least 4 major spiral arms and several shorter arm segments. Because we are in the disk and surrounded by gas and dust, we cannot see much of the spiral structure directly, so we are not yet sure of its exact shape. This photograph is of a classic spiral-shaped galaxy.
The giant bulge in the center is not a single star, but hundreds and hundreds of millions of stars so closely packed together that they close as one giant mass. We, as our sun, are one of these dots out here in one of the arms.
In 1755, German philosopher Immanuel Kant first put forward the notion that our galaxy was just one of many. Kant proposed the term island universes.
After Hubble's discovery in 1923 of other galaxies, the term island universes was adopted, and this was initially by the German philosopher Kant.
In the 1780s, Sir William Herschel tried to measure the sun's position in our galaxy by counting the density of stars in different directions along the Milky Way.
The importance of Herschel's effort is that he was the first person to try and get a handle on the size and shape of our galaxy. However, the black globules and interstellar gas, black gas, confused all early astronomers, and so he was not able to make an accurate
We are
map.
only able to see a relatively small part of our Milky Way galaxy because the distant stars are obscured by the dust in interstellar space. Prior to the 20th century, most philosophers thought the Milky Way contained all the stars in the cosmos. That is, they thought the terms galaxy and universe were the same thing.
When we look in the night sky from any place on planet Earth, all the stars we see are within our Milky Way galaxy. We are simply looking at the roof of our galaxy. We cannot see any galaxies beyond our own Milky Way.
There are billions of galaxies in the universe. Each galaxy is a grouping of millions, billions, or even trillions of stars, gas, dust, and matter in other forms, all gravitationally bound together. Our galaxy neighbor, the Andromeda Galaxy, is at 2.2 million light-years beyond the Milky Way. Remember that our Milky Way is 100,000 light-years in diameter, while Andromeda is 300,000 light-years in diameter. Andromeda is what our galaxy would look like if we could view it from deep space.
Again, since 1923, we have discovered that there are billions of galaxies in the universe. That's totally insane. So we'll look at some examples of galaxies. This is a member of our local group of galaxies. We have 49 galaxies that are generally moving in the same direction because of their mutual gravitation. Here we see the collision of two spiral galaxies, or the intermingling. The galaxy is being absorbed into the other galaxy. Stars have very little chance of colliding because the space between stars is gigantic. The galaxies consume the stars. You think the fruit burst gum starburst was made for you, and it was named actually after the starburst galaxy. Again, just showing you the various shapes that exist in galactic structures. Here we see what we believe are two galaxies in collision, one coming this way, one coming that way, forming one larger galaxy. Here we see the famous M81 and M82 galaxies. This is an actual space photograph, and you can search them on Google. The antenna galaxies. Look at that. More galaxies and collisions. Hundreds of thousands of light years across. The mice galaxies. Just a mere 300 million light years from Earth. This is where Professor McCann was born, in the ARP 273 galaxy. Coolest galaxy in the universe. In this image, remember, as we look further and further out into space, we see thinner and thinner slices of the angles of the night sky, and we soon lose an ability to detect individual stars and can only detect galaxies. So each of these dots and shapes is a group of billions of stars of individual galaxies. Here, just for fun, is a close-up of the starburst galaxy. Again, Perseus, a beautiful galaxy. And again, to blow your mind, each of these objects is a galaxy. And the field of view we're looking at is over 1.5 million light years in diameter. Another massive group of galaxies, only 6 million light years from side to side. What's the furthest galaxy we've detected? This is it. What's the largest galaxy? 6 million light years across. Our galaxy is 100,000 light years. Galaxy Able is 6 million light years across.
By 1919, astronomers were in an uproar about the question of other island universes and the distance to nebula, such as M31. This debate about the size of the universe was known as the Shapley-Curtis debate. Shapley had previously established the distance across the Milky Way at roughly 100,000 light years in diameter. The debate focused attention on the size of the universe, but nothing was decided because no one yet had any firm evidence to demonstrate how far away any spiral nebula like M31 were.
So the beautiful Andromeda galaxy we've been looking at in 1919, this is what it looked like, a gray blob in space. This was our best photographic image.
This first photograph is an image of galaxy M31 from 1919. The second image is a picture of the same galaxy from 2009. A key to help solve the problem of how to measure distance in the universe was a type of star known as a Cepheid variable. Unfortunately, at the time of the Shapley-Curtis debate in 1919, no one on the planet was smart enough to figure out a way to do it.
We have stars that actually turn themselves on and off. If you can imagine, how do you turn a star on and off? Well, they do, and they have periods of up and down cycles, and the dimming of light allows us to calculate distance.
Then, in 1923, Edwin Hubble took his famous photo of M31, then known as the Andromeda Nebula. By referring to older images, he discovered a Cepheid variable in one of the arms.
The top three images show, from left to right, star off, star semi-on, star fully on, a Cepheid variable star. You could calculate distance with this.
Using the light fluctuating properties of this type 1 Cepheid allowed him to calculate distance, and he determined that M31 is some 2.2 million light years beyond the Milky Way. He proved M31 was not a globular cluster or a nebula in our galaxy, but rather an enormous separate stellar system, a separate galaxy. By using the light curves of known Cepheids, which is a plot of the star's brightness versus time, and applying the inverse square law of light to the amount of change in the star's luminosity, Hubble was able to calculate the distance to that star in the Andromeda Nebula. Edwin Hubble had discovered the realm of galaxies.
1923, we're less than 100 years from this discovery. Just a beautiful image of Hubble at work.
We now know that the Milky Way galaxy is one of the many billions of galaxies in the universe. We also know that the Andromeda Galaxy is the most distant object in the universe that can be seen with the naked eye. And at that, it is still only a dot in our night sky. And lastly, we know that the basic types of galaxies are spiral, elliptical, and irregular. So how are galaxies spread throughout the universe? Galaxies tend to cluster in groups. These groups of galaxies tend to cluster into even larger groups of galaxies known as superclusters. The local group is a term used to describe a cluster of 49 galaxies, of which the Milky Way is a member. It includes 3 major galaxies and 46 minor galaxies.
So let's look at this.
This is an image of the local group. So how local is local? Well, we consider the local neighborhood of our universe to be anything in the area of 5 million light years from Earth. So how much space stuff is within 5 million light years? There are 3 large galaxies, 46 dwarf galaxies, and 4 trillion stars.
And remember, a dwarf galaxy like the Andromeda or the Phoenix or the Triangulum is simply a galaxy that measures less than 100,000 light years across. So within 5 million light years of the Milky Way, this is all there is.
Voids are volumes of space hundreds of millions of light years across that contain almost no galaxies.
So in this module, we've learned about the structure of the Milky Way, the Shapley-Curtis debate on the distance to M31, the function of Cepheid variables in Hubble's discovery of galaxies, our local group, and the concept of void spaces. The distances between galaxies, the intergalactic space, are the void spaces, and they are much larger than galaxies.